Hello, in this video we are going to work through example 11 where we are still talking about calculating probabilities with the binomial distribution in chapter 4. Example 11 says the lifetime risk of developing pancreatic cancer is about 1 in 78 or 1.28%. Suppose we randomly sample 200 people and let x the number be equal to the number of people who will develop pancreatic cancer. So the first question is, what is the probability distribution for x? So let's work through our characteristics of a binomial distribution. First off, our random variable is defined in terms of counting the number of trials that exhibit a certain characteristic. So the number of people who would develop pancreatic cancer. So that would mean that developing pancreatic cancer would potentially be our success in the binomial distribution, if it is binomial. We do have a specific number of trials, 200 people. We also have only two options with those trials, developing pancreatic cancer or not developing pancreatic cancer. And we can find a probability for developing pancreatic cancer, which would give us one for not developing. And it's going to be the same for every single person, so every trial. So this is definitely a binomial distribution. So we will write that x is similar to a binomial distribution. Our n value is 200. And our probability is 1.28% in decimal, so 0.0128. And there we go. Now for part B, we're going to use a calculator to find the probability that at most 8 people develop pancreatic cancer. At most 8, that's going to include 8, means x is less than or equal to 8, so we want the probability that x is less than or equal to 8, and we can put that straight into our calculator as a binom CDF, since it's a cumulative, with 200, 0.0128, and 8 as our x value. So flipping over to our calculator, we are going to do second vars, which gets us to distribution, and then scroll down to binom CDF, enter. We have 200 now for our number of trials. Our P is 0.0128, and our X value is 8. Paste that in and enter again to execute, and we get 0.9988 if we round to 4 decimal places, which is extremely high for a probability, because if you recall, probabilities max out at 1. So this means that almost guaranteed you will have 8 or fewer people in a sample of 200 that will develop pancreatic cancer. So is it more likely that 5 or 6 people will develop pancreatic cancer? And we're going to justify our answer numerically. Okay, well, is it more likely? That should make you think about probabilities. And that 5 or 6 people develop cancer. That's exactly 5 or exactly 6, since it doesn't say anything about less than or more than or at most or at least. So this is going to be x equaling 5 or x equaling 6. So we can calculate the probabilities of both of those options and compare them to determine whether which option would be more likely. So we are first going to calculate the probability that x is equal to 5. That's going to be binom PDF in this case, because we're talking about exactly equal to 200, 0.0128, and 5. And just to write out what we need here for the other option, the probability that x is equal to 6 is going to be the same as what we just had, except for a 6 instead of a 5. Okay, now flipping over to the calculator, we need the same as our previous entry, but we need a 5 or a 6 there. So in order to get the previous entry, I'm going to use second and then press this enter button down here because it'll pull up entry. So it pulls up the previous entry, and now I'm going to scroll over to the 8 and enter a 5 instead and press enter. So 0.95, I will round it to 4 decimal places, which is going to give me a 5 0. Oops, except I made a mistake. I'm accidentally using the CDF instead of the PDF, so I do need to start over. Sorry about that. Oops, so I need the PDF, and then 200, 0.0128, and 5. There, that's better. Now it's 0.0707. Okay, and then to do 6, now this one I can use my previous entry because it's a PDF and all I need to do is change this 5 to a 6. So there we go. This is 0.0298 rounded to 4 decimal places. And now we can compare these two values. Oh, that didn't work. There we go. Compare these two values, and the larger one is going to be more likely. Larger probability means that it's more likely to occur. So